Hello friends, continuing with the topic of dimensional analysis, today we take up applications of dimensional equations. There are three applications of dimensional equations. Number one, dimensional equations are used to check physical correctness of a physical equation derived to represent a physical phenomenon. Number two, dimensional equations are used to find the relationship between the relevant physical quantities with regard to a physical phenomenon. Number three, dimensional equations are used to convert the unit of one system into corresponding units of the other system. Okay, so let us take up one by one. Now, number one, to check physical correctness of a physical equation derived to represent a physical phenomenon. Consider the equation E equal to mc square. According to principle of homogeneity, for an equation to be physically correct, the dimensions of each term on both sides of the equation must be same. Therefore, dimensions of left-hand side, that is energy, are 1 in mass, 2 in length, minus 2 in time, and dimensions of right hand sides are 1 in mass, 2 in length, minus 2 in time. Since dimensions of left hand side are equal to dimensions of right hand side, therefore the equation is correct. Now, assignment 2.4 continued. Question number 4. Check whether the following equation is physically correct or incorrect. T is equal to 2 pi root L by G. Now we take up second application of dimensional equations to find the relationship between the relevant physical quantities with regard to physical phenomena. For example, derive the relation time period of simple pendulum T is equal to 2 pi root L by G. Suppose the time period of simple pendulum T depends upon xth power of the mass of the bob, yth power of length of the pendulum, and zth power of the acceleration due to gravity as shown. That is, T is directly proportional to m power x, T is directly proportional to L power y, and T is directly proportional to G power z. Or we can write this expression as T directly proportional to m power x, L power y, G power z on combining all the three proportionalities. Or we can write it as T equal to K into m power x, L power y, G power z. Let us mark it as equation 1, where K is constant of proportionality, which is Young's value 2 pi. Now, for the equation to be physically correct, the dimensions of each term on both sides of the equation must be same according to principle of homogeneity. Therefore, we have dimensions of left hand side as 0 in mass, 0 in length, 1 in time, and that of right hand side as x in mass, y in length, and z of Lt minus 2. Or we can write it as 0 in mass, 0 in length, 1 in time, and on right hand side we can write it as x in mass, y plus z in length, and minus 2z in time. Now, comparing dimensions of each term, we have x equal to 0, y plus z equal to 0, and minus 2z equal to 1, or z equal to minus 1 by 2. Therefore, we can calculate y as y equal to minus z, or minus half, it is equal to half. Now, substituting the values in equation 1, we get T is equal to 2 pi. For K, we have 2 pi, m power 0, L power half, G power minus half, or T is equal to 2 pi root L by G. So this way we can derive the expression of time period of simple pendulum T equal to 2 pi root L by G using dimensional equations as an application of dimensional equations. Now assignment 2.4 continued. Question number 5. Employing the method of dimensions, obtain an expression for acceleration of a particle in circular motion. Question number 6. Assuming the mass of a largest stone that can be moved by a flowing river depends upon velocity v, the density rho of water, and on g, the acceleration due to gravity. Show that m varies with sixth power of velocity. And you try to solve these numericals. And now we take up the third application of dimensional equations, that is to convert the unit of one system into corresponding units of the other system. Consider the equations 1 meter equal to 100 centimeter, where meter is unit of MKS system and centimeter is unit of CGS system. So 1 is numerical value and 100 is also numerical value, and M corresponds to the system of units MKS and CM correspond to system of unit CGS. So parallel equation we have N1 U1 equal to N2 U2, where N1 corresponds to numerical value 1 and U1 corresponds to MKS system, and N2 corresponds to numerical value 100 and U2 corresponds to CGS system. Okay, so these are two parallel equations where we can compare the meanings of N1, N2 and U1, U2. Okay, let us see. Now we come to the text, where N1 and N2 are numerical values and U1 is equal to M1 raised to power A, L1 raised to power B, T1 raised to power C in system 1, and U2 is equal to M2 raised to power A, L2 raised to power B, T2 raised to power C in system 2, are units of same physical quantities but in different system of units. Now substituting the values of U1 and U2, we have N1 into M1 raised to power A, L1 raised to power B, T1 raised to power C equal to N2 into M2 raised to power A, L2 raised to power B, T2 raised to power C. From this equation we can calculate the value of N2, which is equal to N1 into M1 raised to power A, L1 raised to power B, T1 raised to power C, divided by M2 raised to power A, L2 raised to power B, T2 raised to power C, and it is equal to N1 into M1 by M2 raised to power A into L1 by L2 raised to power B into T1 by T2 raised to power C. Thus we can calculate the numerical value in system 2 using dimensional equations. Assignment 2.4 continued. Question number 7. The unit of force in CGS system is dyne and in FPS system is poundal. How many dynes are there in 1 poundal? Given 1 pound equal to 453.6 grams, 1 feet equal to 30.48 centimeter, and 1 poundal is equal to 13,826 dynes. Assignment 2.4 continued. Question number 7. The unit of force in CGS system is dyne and in FPS system is poundal. How many dynes are there in 1 poundal? Given 1 pound equal to 453.6 grams, 1 feet equal to 30.48 centimeter, and 1 poundal will be equal to 13,826 dynes. This should be your answer. Now let us solve this problem. Let there be x dynes in 1 poundal, then we can write x dynes equal to 1 poundal, or we can write x equal to 1 poundal by 1 dyne. Now we take up the equation N1 U1 equal to N2 U2. And dimensions of force are 1 in mass, 1 in length, minus 2 in time. We substitute the values of 1 poundal and 1 dyne. Okay, so we put 1 in place of poundal, we put M2 raised to power 1, L2 raised to power 1, T2 raised to power minus 2, divided by M1 raised to power 1, L1 raised to power 1 and T1 raised to power minus 2. Raised to power means their dimensions are there. These are their dimensions. Or we can split this division as 1 as it is, 1 as it is, and we can write here M2 by M1 raised to power 1, L2 by L1 raised to power 1, T2 by T1 raised to power minus 2. Now we substitute the values. In place of M2, we put 453.6 grams, because the units of numerator and denominator must be same, since 1 poundal is equal to 453.6 grams. So in place of M2 we write 453.6 grams, and in place of feet we write 30.8 centimeters, and in place of time we write seconds. In second is the unit of time in all the systems. So we substitute the values, and on simplification we get 1 x equal to 13,826 dynes. Okay, so this way we can solve this problem. So we can use dimensional equations for conversion of units from one system to the other system. And now assignment 2.4 continued. Question number 8. The value of acceleration due to gravity is 32 feet per second square. What will be its value if the unit of length is a mile and that of time is a minute? And your answer will be 21.81 miles per minute. And now drawback oblique limitations of dimensional equations. Number 1. Dimensional equations conveys no information about dimensionless constants and variables. Number 2. Dimensional analysis fails to establish the exact form of a physical relation. A. If a phenomenon depends upon more than 3-dimensional quantities. B. A physical relation consists of more than one term. C. The physical relation involves trigonometric and exponential functions. Number 3. Dimensional equations also does not convey whether the quantity is scalar or a vector quantity. Thank you so much. God bless you. With this we finish with dimensional analysis, and next time we will start with kinematics, second unit, kinematics.